And I said, I want to come back, I want to speak again, I want to speak on something technical. What could I do that would be of use to the SimCon audience? And he suggested that I talk about using the PJSIP channel driver in Asterisk to connect to Simwood. So just out of a show of hands, how many people know about Asterisk? Probably everybody in this room. I've been using Asterisk for about 18 years. I think one of my claims to fame is that I helped write the first O'Reilly book on Asterisk. And so you've been using it for a long time. How many people are using the PJSIP channel driver in Asterisk? A few of you. So the rest of you probably either don't know about it or aren't using it. So it sounds like this will be an applicable topic. How many people here connect to Simwood? Well, obviously that's why you're here, or you soon will be if you're not already. So I think I tried to find something that fits people who are using open source telecom connecting to Simwood, and hopefully this talk will be of use. Now I'm going to start off with some bad news, at least for some of you. And that bad news is that the ChanSIP channel driver in Asterisk has been deprecated. We'll talk about more about what that means here in a second. But if you're using ChanSIP, if your config's in sip.conf in Asterisk, for example, it's time to move on. Now don't panic. That just because it's deprecated doesn't mean you can't use it. We've taken the slow approach to removing ChanSIP and trying to encourage people to move over to the PJSIP channel driver. So for the majority of our users, the PJSIP channel driver has reached maturity. It does everything they need and performs quite well. We recommend moving to it, especially for new installations or migrating existing installations. Now we're going to leave it available in the source code for a little while longer, probably no earlier than 3 years from now. So you have some time to move off of it. But you need to start doing that work of preparing to migrate off of ChanSIP to PJSIP now. Don't wait another 4 years and then be playing catch up. Just as one little fun fact, our commercial PBX switchbox has been using PJSIP exclusively since 2016. So it's very possible to use PJSIP for everything you need and really recommend it at this point. So you might be asking yourself, well, why PJSIP? If we roll back history a little bit and we talk about ChanSIP, it was not super performant for a high number of calls because of the threading model. There was one thread for all the UDP traffic. There was one thread for each of the TCP or TLS or WebSocket or secure WebSocket connections, and then one thread for each channel, at least generally. But it meant if something was blocking, like maybe a DNS lookup or something like that, it could bring your whole system to a screeching halt because it would block all those other UDP connections. PJSIP, on the other hand, does a much better threading model. It does a thread for the main traffic distribution, end threads for all the traffic handling, so it's not limited to a single thread. And then obviously each new WebSocket or secure WebSocket connection has its own thread. And each new channel has its own thread as well. And there's a great thread pooling library that we use to make that make sense. What it means is that your system can handle more concurrent calls, handle that more efficiently, and won't get blocked by something silly like a DNS request timing out or something like that. Another great advantage of using PJSIP is endpoint identification. So all traffic with PJSIP is associated with a particular endpoint. And we have some new mechanisms for identifying which endpoint should be matched to that traffic. And we'll talk about that a little bit more. But these endpoint identifiers are also pluggable. And then just a random list of other things that ChanSIP doesn't have, but PJSIP does. It's got music on hold pass-through. It's got SRV and NAPTR load balancing and failover built in. That all works well. What I call line support and outbound registrations. We'll talk about that a little bit later. But the ability to have, if you're doing outbound registrations, have those inbound calls match on the right endpoint. Multiple media stream support. Multiple IP matching for inbound traffic, so it's easier to match on ranges of IP addresses, and multiple contacts. So how many people in Asterisk would like to have, I have 3 or 4 phones, but I all want to ring them as the same extension? I've been asking for this for years. It's finally in PJSIP. You can do it. It's a fantastic thing. So now let's talk about PJSIP itself. Where did it come from quickly? And then we'll dive into the configuration of actually how do you get this stuff to work. So PJSIP is not something that was written by the Asterisk development team. It's actually a standalone project. It's available at pjsip.org. It's an open source project. It's created and maintained by a company called Telu. It's been around since 2005. Runs on Windows, runs on Linux, runs on Mac, runs on embedded systems, runs on Android, runs on iOS. And it's widely used. A lot of the Android soft phones use it. A lot of physical phones are actually built upon the PJSIP platform as well. So inside the Asterisk project, we decided to use PJSIP as our lower level SIP stack to replace ChanSIP. We use a few of the higher level functions for outbound registration and pub sub when it makes sense, but we really focused on using it as the underlying SIP model and then built some additional features on top of it. And we also contribute back to PJSIP. We've been contributing patches back upstream to the PJSIP project since Asterisk 12, which was released in December of 2013. So we have a 7-year history, or 6-year and a little bit history of contributing back to the PJSIP project. We've contributed pluggable DNS support, some crash fixes, some transport-related fixes, and we've taken the attitude, which I think is a very healthy one in open source, that we don't want to just fork PJSIP and go off in our own direction, that we really want to be a good open source citizen and continue to do everything we can to support that project and help it and make sure it continues to grow and thrive. Now I want to talk just briefly about things we don't use out of PJSIP, just so that there's no confusion there. We don't use the library called PJ Media, which is their RTP engine, RTCP codecs. We don't do any of that. We've got our own stuff in Asterisk for that. We don't use their DNS handler. We've written our own that tends to work a little bit better for Asterisk, and so we don't use theirs. And we don't use their PJ SUA library, which is a little higher end. We don't want to be just a user agent. We do more interesting things at the SIP level. So we've tried to be as modular as possible, as pluggable as possible, not reinvent the wheel, use what things make sense, and try to make explicit configuration with sensible defaults. Now, anybody who's used to using ChanSIP, you've probably come across some settings in the configuration, and you're like, what does that mean? I think my favorite is one that says insecure equals. Anybody familiar with that one? And your answers are yes or port comma invite, and you're like, well, what does insecure equals port comma invite mean, right? So with PJSIP, we've tried to be a little better at naming things and being more explicit with what things do. Just really briefly about the installation of PJSIP, you can either install PJSIP by itself and then install Asterisk and have Asterisk reference that copy of PJSIP that was installed independently, or with Asterisk 16 above, we actually bundle PJSIP with Asterisk, and you can use the bundled version at the time you install Asterisk. And there is slight differences if you use the bundled version or the unbundled version, but for the most part, it just works either way. Don't need to spend a lot of time on that. So before we dive into the Asterisk configs themselves, I want to just talk about Asterisk configs in general, and it's a slightly controversial subject. Who here is absolutely in love with the Asterisk configuration files? I am not. One of the reasons I started writing a book many, many years ago on Asterisk was so I could actually get that straight in my head, and I figured if I could explain it to someone else, then it would stick in my head. So, but most modern things in Asterisk are built on top of a configuration engine that we call Sorcery. So it's kind of a unified layer for configuration and for data storage. It has pluggable backends, so we can say, hey, this is going to be stored in a database. This is going to be stored in a config file. This is going to be stored some other method. So most of the modern modules in Asterisk use this Sorcery library. It's also nice that it enforces documentation. You can't have a config option in there without providing the documentation for it. And the documentation in our wiki gets automatically updated by any changes to the documentation in the code. So that's kind of nice. And it kind of provides some guarantees for developers that either it's going to work or not work, but there's no middle ground there. It's also got a caching layer to it so that we cache configs in memory. so that the system can be more efficient. I won't go into too much detail on this. You can read my slides faster than I could read them. But just know that there's some great caching in Sorcery to make that more efficient, especially if you've got a back end that's, say, in a database or something that's a little more CPU intensive to go out and query information from. Let's talk specifically about PJSIP configuration here. Like I said, it uses Sorcery. There's several different object types that I'll talk about here in a few minutes, and we tried to name those after industry terms or technology terms. How many people are familiar with users and peers and friends in ChanSIP? Anybody ever really understand those? I mean, I taught 7 years of Asterisk classes. I wrote a book on it, and it still confuses me, especially like inbound calls matching on a peer instead of a user. So we tried to get away from that and tried to use industry standard terms for that. One of the nice things about using Sorcery is it means we won't allow invalid objects to be created. So if you've got a bad configuration or invalid values given as a parameter, it won't let those be accepted. The other nice thing about PJSIP is that the command line interface of Asterisk reflects the truth, no matter where the source of truth is. With ChanSIP, if you've got a database backend, you can ask the CLI something, and it only knows about the things that came from the config files and not the things that came from the database. And so that could be confusing as well. So PJSIP does a better job there. So we're going to talk about 6 configuration options, these configuration objects. This is really the meat of what I'm going to be going through for the next few minutes here. So we're going to talk about transports. These are, how do I get the communication from Asterisk to this endpoint? Is this over UDP? Is this over TCP? Is it encrypted with TLS? Am I going to be listening on a particular IP address? Am I going to be listening on a particular port? These sorts of settings. That's all in your transport settings. Next, we're going to be talking about endpoints. This is something that we're going to talk to. What's its IP address or its host name? It's going to reference to some of these other objects, like how do I authenticate to that endpoint? It's going to say, my auth is this, and then we'll point to an authentication object. It may have addresses of record, which will point at an AOR object, that sort of thing. So this is just configuration where we're talking to another SIP device. We put information about that SIP device in the endpoint. Next thing is addresses of record. This is mainly used for holding inbound registrations. So you can think of it as a small little table or a small little database, and as phones register as a particular extension, they will be placed into that addresses of record object. And like I said, you could have multiple phones register as the same endpoint, but this AOR's record will hold all the different phones that are registered there. And then from the dial plan, when you go to call out to that particular endpoint, you can say, hey, call all these addresses of record at once or iterate through them in some fashion. You can choose how you do that. The next section we have is called an identify object. This is the one that I wish it was called an identity and not an identify, but it wasn't up to me. An identify object it allows Asterisk to identify incoming traffic and say, I recognize that traffic as belonging to this endpoint because it matches this IP address or because they've logged in using this username and password combination, that sort of thing. This is really for inbound calls saying, how do we match that to a particular endpoint? That was always the piece in ChanSIP that was the hardest to get. We've made it very obvious and very easy with PJSIP. We talked briefly about auth before. This is just saying, how is this endpoint going to authenticate to us, or how do we authenticate out to this other SIP endpoint? And last but not least, if you're doing outbound registrations, let's say you don't have a fixed public IP and you want to send calls, make sure your calls from Simwood come to you, but you're doing a registration trunk rather than an IP-based trunk, then you'll need an outbound registration as well. And we'll show an example of this here in a minute. So these are really our 6 objects. For those who are visually oriented, I had to put at least one other graphic in the slides just to keep you awake. Don't let this scare you off. Yes, it's an entity relation diagram, and I could tell you that this means, many to one, and this means, one or more, and means one or zero options. But the idea is that, that we use the identify object to say, hey, traffic is destined for a particular endpoint. That endpoint may tie to a transport, an address of record, authentication. Outbound registration obviously ties to a transport and some sort of authentication. And addresses of records will have more one contact inside of those. You can read on the other side that how each of those ties to each other. But if you just kind of look at this and kind of go top down, you realize that, either you've got an outbound registration that ties to some sort of transport, so I'm doing this over UDP or I'm doing this over TCP, and I'm authenticating this way. Or you've got an endpoint that's got to have a transport, authentication, and addresses of record, and an identify section just points at an endpoint. Not too difficult. It's not as difficult as it might look graphically up there on the slide. So let's go through each one of these objects and just give you some examples and point out some things that may be useful specifically when connecting to Simwood. This is a section taken from one of my sample configuration servers that I was playing with this week. So we just put a name in square brackets. I like to, for my own sanity reasons, I like to say what type of an object is in the name. So I called this transport-TCP just to remind myself, oh, that's what that one was. So we say type equals transport, so we know that this is a transport object. Protocol is going to say, are we going to use UDP? Are we going to use TCP? If we were going to be using TLS, I didn't put the TLS examples here because it was longer than the screen would fit. But you would say TCP, and then there's some config options for here's where my certificate file is, and here's where my key file is, those sorts of things. The next thing we need to do is have a bind. This is saying I'm going to be listening for SIP traffic on this port or on this IP address. It's going to default to port 5060. You can put :5062 or 5070, or if you want to listen on some non-standard port, just put a colon and the port number on the end. You can bind to multiple IP addresses, which is very handy with PJSIP. Or you can have multiple transport options and each one listening on a different IP or a different port. That was something that was also very hard to do with ChanSIP, is to say, hey, I want to talk SIP on this network using these options, but I want to talk over here on this other network on these options. That's very easy to do with PJSIP by defining multiple transport options. If you're behind NAT, you may want to set up local net options to say, hey, this is on my local network. Anything on this, anything on this subnet will be local, and I don't need to do any NAT translation or NAT tricks to do those sorts of things. If it's outside of what's in local net, then you can set an external media IP and external signaling IP to use for things that are outside those subnets that are listed. And you can put CIDR notation to do a subnet like I've done here with the /24. All right, so that's our transport. The most important object out of all of these, I think, is the endpoint. So I called mine Simwood endpoint. Nice generic name, right? We know it's an endpoint because we have type equals endpoint. The context is when calls come in from this endpoint, where in the dial plan do we want them to go? So I've created a context in extensions.conf called calls from Simwood. That way I know when they hit that context that those were calls that came from Simwood. Next up, we have an allow line. This is how we specify which codecs we're going to allow on that particular endpoint. And so I said, negate all of them. It means I allow nothing. But then in order of preference, I want G722, ALA, and then MULA. You could change that around. You could put Opus or whatever your preferred codecs are there. Just an example here. Next up, I've got direct media equal no. This is saying I want Asterisk to stay in the signaling path and in the audio path. I don't want the audio endpoint to endpoint because maybe I want to do some call recording or listening for DTMF tones for features and those sorts of things. Next, I'm going to reference the address of records section. So we'll come to our AOR's object here in a minute. But it's saying for this particular endpoint, all the addresses of record are going to be in this other object called Simwood-AOR. I'll show you that in a second, like I said. Same thing for authentication. I'm not going to force Simwood to authenticate to me, but for my outbound authentication to Simwood, I need an outbound auth section. It's going to be called Simwood auth. I'll show you that object here in a minute. It's just referencing that other object to say this is how I authenticate to Simwood. Last but not least, if you were here last year, you probably heard Simon go on and on about caller ID in the UK and how you need to be smart about that. One of the best things you can do is send the P asserted identity header. And this is simply, this setting here, send PAI is saying send that header so that you have both the number and name in the caller ID as well as the asserted identity. Any questions on this before we move on? Hopefully I'm not boring everyone to death. All right, let's look at the addresses of record of the AOR object. So I've called it Simwood AOR, so I know what it is. The type is AOR. And here's where I put my contact. Now here I've just got a single one. This contact is SIP, out.simwood.com. Simon's going to be happy that I tell people to use out.simwood.com instead of just pointing at an IP address. Why is that? Because when they do maintenance, they're going to shift that over to one of their other locations, and you're going to be none the wiser because it just works. Here on the end, I've put semicolon transport equals TCP, and I have to put a backslash before the semicolon because in the Asterisk config files, a semicolon begins a comment. So one tricky thing here is if you wanted it over TCP instead of UDP, put backslash semicolon transport equals TCP. All right? This is going to say, hey, when I go to talk to that endpoint, now I know that that's at out.simwood.com. Simon looks like he's got a question.
Yeah, sorry, Jared.
Mm-hmm.
Just go back a step.
Sure.
So is that that's calls from Simwood?
No. This is the AORs here, Simwood AOR. Yeah. This is the context in the dial plan. Yeah. These are the addresses of record for this endpoint.
So you address the record of outbound locally. That was the bit that confused me.
Yes.
The context suggested it was inbound.
The context is for inbound calls. Addresses of record is for outbound calls.
One of the big issues we have is people defining peers with out.simwood.com and then opening tickets that their inbound is failing for 50% of calls every time DNS changes.
Yes. So I'll talk a little bit more about that when I talk about the identify object. But yes, this is saying for outbound calls, this is who I go talk to. And you could have multiple contacts in there. You could say, I want to go to out.london.simwood.com. And then if that fails, then go to out.simwood.com or those sorts of things. No, that's the identify object, which I'll show in a second. Yep. No worries. All right, so this is our endpoint. Like I said, it refers to an AOR's object. It refers to an auth object. So again, here's our AOR object. Here's our identify object. This is what we use for inbound. This is how an inbound call gets matched up with a particular endpoint. So we know it's an identify object because it says type equals identify. We know we have to tell it which endpoint to map to. So in this case, it's our Simwood endpoint that was 2 slides earlier, right? And then we have these match equals lines where you can either put an individual IP address or you can put a subnet mask, a CIDR notation. And so you can match on subnets, you can match on IPs. For simplicity here, I even went and put a comment on each of these so you know which of the Simwood IPs these IP addresses match up with. But they may add new ones over time. So it's better not to just use this list. Go look at their knowledge base. They keep that updated, for their inbound SIP page, and these may change over time. Questions with this? Pretty easy, right? Incoming call comes in. If it's coming from one of these match IP addresses, it's going to send it to this endpoint. Know that it's from that endpoint. Last but not least, here's the example for outbound registration. And again, this is only used if you're using a registration trunk. I'm guessing probably the vast majority of you are not. Hopefully you're using IP trunks and not registration trunks. But because Simwood does support them, I figured I might as well show the example here just in case you need outbound registration. Again, type equals registration. Outbound auth equals Simwood auth. This is how we're going to authenticate to Simwood. you have a server URI and a client URI. The server URI is just SIP : and which server you're going to register to. So I'm going to register to reg.simwood.com, again, using TCP as the transport. The client URI is my username on their system at the server that I'm going to register to. So in this case, I pretend that my user ID is 901234-L003. It's not really it. That's made up. Don't use mine. It doesn't work. But that gives you an idea there. Retry interval is how often we retry if we don't get a successful response back from that particular provider. This is a little aggressive. I was doing this for some testing. It's saying every 60 seconds retry. That's probably a little aggressive. Same thing with the expiration. It defaults to an hour, but if you want to be a little more aggressive, if your IP address is more likely to change more often, in this case, I've got it set to 2 minutes. So it's going to re-register every 2 minutes. Sorry, Simon, this is going to pound your servers a little bit, but that way, if my IP changes, I don't have to wait an hour for it to re-register and get the updated IP. Again, we're going to point at a transport here. In this case, that transport, that was the first object I showed called transport TCP. And last but not least, I'm going to set an object called the contact user. This is the user that's going to go in the SIP messaging. So when the call comes back, I can then match it back to the proper endpoint and into the dial plan with something that I can identify on that call. I typically set this as to whatever my main DDI or DID on that particular trunk is. But you can set that really to whatever you would like to have it. Just helps you identify how this is traffic coming in on this trunk versus traffic that may be coming in on another trunk. Questions up to this point? Does that make sense?
A quick question on the last slide, Joe, if I may.
Sure.
Since you said that the transport is transport UDP for that whole section, right, the penultimate line, is it strictly necessary to have transport TCP on the client and server URIs?
It's probably not, but I do it out of an abundance of caution. I have seen things where people just kind of assume everything is TCP, but they've got it set to a transport that's UDP, and so that it doesn't cause problems. I always just, if I know I'm going to be using TCP, I explicitly put that transport there.
So braces. Okay, thank you.
It's better to be safe than sorry. All right, any other questions? Not too difficult. I think it's probably new to some of you, but I will bet that if you take the time to go play with the system, set this up, you'll say, oh, that makes so much more sense than users and peers and friends.
Can I have that contact user as a prefix so I can mention dial plan prefix?
I think there's a way you can put dial plan variables in there. I'd have to go look at the exact syntax for that. I don't remember that off the top of my head, but yes, I'm pretty sure there's a way to do that.
Good question from
Either will do, or both. That one works. Cool. Got a question from Darren on the stream.
Okay.
When you were showing the slide earlier with the contact, where you had sip:/out.simwood.com :5060.
Yep.
Does that break SRV, or does that respect SRV?
It absolutely respects SRV. So if this was if out.simwood.com had an SRV record, it would absolutely look up the SRV record and do the right thing with regards to SRV records. Unlike ChanSIP, which didn't totally work with SRV records, or it would cache the results too long, or those sorts of things. So absolutely does the right thing with SRV.
Yeah, fabulous. Thank you.
Oh, Dan had the same question. All right. One thing you can do is if these 6 objects are, 5 of the 6 objects are too much for you to wrap your head around and you want something that's slightly simpler, there is another configuration file called PJSIP_wizard.conf where you can use a slightly different syntax to build all those different objects kind of at the same time. So I'm going to show 2 different examples. The first example is going to be if you had a phone, you're trying to set up a SIP set of SIP objects for a phone that's going to register to Asterisk. And then the second example will be a set of configuration for Asterisk talking out to an ITSP like Simwood. So here's the example from a phone. And so we give it a name in square brackets. We say type equals wizard. Say it accepts registrations, it accepts authentications. And then we have things like inbound auth / username equals 1000. What that's really doing is going and building an auth object and setting the username field in that auth object to be 1000. Inbound auth password. So this is going to set the password field in the auth object to secret. You could just as easily say type 1000, type equals auth, username equals 1000, password equals secret. It would be the exact same thing. Does that make sense? Endpoint / allow equals your codex. That would be the same thing as creating an endpoint object, setting the allow field equal to your codex, or your context equal to users. Does that make sense? So you can kind of build those objects at once in kind of wizard fashion without having to go through and specify 5 different sections of your config file for each type of object. The one thing you cannot do in a wizard is build a transport. So you always have to do your transports in PJSIP.conf, but everything else, your endpoint, your authentication, your addresses of record, your identifies, all those, your outbound registrations, everything else you can do in kind of wizard format here. Here's the same sort of an example, but this for connecting to an ITSP. Again, we say type equals wizard. In this case, we're sending authentication. Rather than accepting authentication from that endpoint, we're sending authentication to that endpoint. We're sending registrations to that endpoint. In this case, it's a register trunk that we're connecting to. You say remote hosts equals sip.myitsp.net. That's building those contacts out in the AOR object. Outbound auth is creating an auth object with a username and password, and our endpoint creates an endpoint object with the context set to default in the dial plan. So just another handy way to kind of in more concise terms build these same sorts of objects that we talked about on the previous slides. That make sense? All right. I'll point out here that the documentation is on the wiki, and like I said earlier, it is kept up to date. It should be automatically updated nightly based on what's put in the source code. So if we go and add a new configuration option to one of these objects, by the next day, the wiki should be updated with the proper documentation for that. Like I said, the Sorcery configuration library that we use kind of forces us to do the right thing and document everything. I will point out that the sample pjsip.conf file that comes with Asterisk doesn't list every single item, doesn't list every single parameter. We've kind of gotten away from that and put it all on the wiki and tried to make a more sane sample config file in the sample. So please, if you don't learn anything else, this is all on the wiki. It's all documented. There's much more detail there, but go to wiki.asterisk.org and you can find out more about that. So if I don't leave you with anything else, the last thing I'll tell you is now's the time to start moving to PJSIP. It will be better for you. It will be more performant for you, and it may save some of your sanity and help keep you from going bald like I'm going bald. So with that, any other questions? David.
Thank you. This is less of a question and more of a shameless plug. Because if anybody is very interested in PJSIP, I just happen to be running a training class next week about introductory command line asterisk, PJSIP, and a bit of troubleshooting.
Fantastic.
So I just wanted to point that out.
So reach out to David Duffett if you want some training.
That's fabulous. Any other questions, anybody? Don't be shy.
Any other questions on the stream?
Not at the moment. But Darren's typing. No, he stopped. No, I think we're good on the stream. So
I'm here. I'm here today. I'm here tomorrow. I'm Jay Smith on Twitter. Reach out to me if you have questions, concerns, comments, complaints, rotten tomatoes. I'm here to help. Try to make things better for open source telephony. So thank you.
That was awesome. Thank you, Derek.